Hello and welcome to the channel. My name is Anirudh. I'm a software engineer with more than 5 years of experience in fintech. Today, we will build a Java-based backend application using Spring Boot framework, and we will see how it will help our influencer friend set up their merchandise store. We will go from the low-level design, get to the coding part so that you will understand how Spring Boot actually powers some of the biggest tech companies around the world, whether it is Walmart, Netflix, Amazon, Google, and some of the biggest players that are out there. So if this sounds exciting, let's get started. Alright guys, so before we get started with coding, I want you to do some system thinking with me so that tomorrow, let's say Spring Boot framework is not there and you have to implement this in a totally new framework, our thinking process will remain same. So we need to understand the problem statement, then we will get into the coding part. Let's add one user. So this user has some problems. So he came to you saying, Anirudh, I have a certain problem, so we have to save him. Just like in Marvel world, there are superheroes who are saving this world from a particular incident from happening. So we are here to help Mr. User, right? So Mr. User is here and then we need to save him. So what is he saying? He is saying, Anirudh, I want to set up a merchandise store. I want to sell particular items so that I can make revenue, right? So this is a fairly simple ask. What all does he want to sell, right? So this is the first immediate question that at least I get. So I'll ask him, hey user, what all do you want to sell? Then he says, hey, I want to sell some t-shirts. I want to sell some mugs. I want to sell some stickers and so on and so forth, right? I'll say, hold on, man. You're telling me a very big list. So this seems like a fairly bigger problem than what I anticipated. So I'll gather some questions that he's doing in his business would usually get, right? So I'll ask him, what are some usual questions in your day-to-day operations that you would get, right? So Mr. User is telling me some questions. So let's listen to them. So Mr. User came back and then he said, Anirudh, I have these questions usually, and these are the questions which are frequently asked by my customers also. So I need your help so that we will be able to address these sort of questions. What are them? Let's look at it, right? What is the price of an item? So like obviously, like whenever somebody is purchasing, they would want to know the price, right? And okay, when was this particular order placed? How many products are left in stock so that based on the stock availability, I can place an order. What items are there in a particular order so that I know if let's say there is some dispute, I want to do some sort of refund, I would want to know, right? So these are just general questions that any shop owner or his customer would have in their mind, right? So I said, okay, let's take a step back. Now we will help you set up the store in itself first. Then we will see how we can address these questions in the end, right? So let's look at some abilities, like he as a creator, what all can he get and how it will help his business run, right? So as a creator, what all can he do? Let's write it down, right? So we are saying as a creator of this store or as a owner of this store, what all you can do? You can create a product, you can update a product, you can delete a product, and you can, of course, once you create, you should also be able to read a product, and along with that, you should also be able to see all the products that are ever created, right? So these are some abilities that I can think of, right? As a creator, he should be able to do all this. But as a customer, what all can I do? I should be able to, of course, again, read all products, read an individual product so that I can see its details, and I should be able to place an order and view my order history, right? This is fairly how most of the stores work. So from all this discussion, we understood there will be two sort of things around which the entire story is going to revolve. One is a product and one is the order. So let's add them. So we'll have a product, and this product will have certain attributes to it, right? So a product will have its name, product will have its description, it will have its price, and how much stock is available for this particular product. And additionally, we will also maintain a category under which it is going to fall. So if it is apparel, then all the t-shirts and shirts will come into that. If it is something of a tech product, then all tech related things will get into that. Apart from this, we will also have one more entity, which is our order. So our order is also important because that is the actual one which is revenue generating, right? So in our order, what all will we have? We will capture our customer name, we will capture our customer email, and we will also collect few more things like, okay, what products are you actually purchasing in this? So this would be some sort of array, right? So this can be one or more. This can definitely not be empty, so because they cannot place a empty order, right? So, and of course the status of the order. So at a high level, I can feel, Mr. User, okay, from our discussion, we have these information that will be captured. So based on this, let's come up with a database diagram, and we will see how all of these will be linked together, what sort of relations that can exist between them, and how we will save it into our database, because handling the data is the key part. So let's add some ER diagram here, and then we will get going. Alright guys, now that we know in a high level what all fields we will have for our product and order, let's convert that requirement into an ER diagram. So let's add one table by the name of products. We will add some beautification. This is basically the beautification given as an option by eraser, so you don't really have to remember any of these. So I'm going to add a table by the name of products. Every product will obviously have a ID, so let's add a ID which is a primary key. It will have a name which will be string. We will have a description which will be a string again. We will have the price of the product. Now this will be decimal because we should also collect the paisa after the decimal point. And after that, we will also maintain the stock quantity. This will be in integer. And apart from this, we will also maintain few more metadata like created at, which will be a timestamp, and updated at, which will again be a timestamp again. So now that we have our base product ready, so we will have to maintain another table where our orders are kept. So let's write down our orders. Now when it comes to orders, let's create one more table. This will have an icon of shopping cart, and then we will keep a color of, let's say, purple, right? Now this orders will also maintain some information in it. So we will start with our standard ID string. This will be the primary key for this table. We will have a customer name. So who is purchasing this? We will have a customer email, which will again be a string, and we will have the status of the order. This can be a enum value, but for our simplicity, we are keeping string. We can have the total amount. This will again be a decimal value, and at what time was this order really placed. So you can have a order placed time, but rather, because I'm going with the meta information syntax of created at and updated at, I'm going to pick the created at syntax. Now that we have two tables with us, which is the products and orders, there is no particular relation between them. We don't know which order has which items, which product is present in which order, so that we can update the stock. So this is where, to rescue us, we are going to create a junction table. So this junction table will help us understand how these both the tables, which is products and orders, are related with each other. So let's write order items. Order items. We will add an icon of, let's say, list. We will add a color of, let's say, blue, right? Now this order item, again, it will have the standard string primary key. Now here something interesting is going to happen. One is, when you're placing an order, you will have the product's price, right? And this price is something which is dynamic. From time to time, based on the demand, the creator can come, they can update, they can decrease based on the sale, right? But this should not hinder our analytics. Let's say tomorrow you want to know how much total sale did I make in the month of March. So I cannot do it based on the current product's price, right? At the time of purchase, how much price was present. So price at purchase will again be a decimal value. This is something which we are going to maintain. And this items that we have, this order items, can be in multiple quantity. So just like in Amazon, you can add an item to the cart. You can also mention how much quantity of that you want. So in the same way, we are going to capture our quantity here, which will be in integer. Now, Ani, I have the order items also. we have three tables. You just added one more, but this really didn't help me in any way. So what are we going to do that will help in our situation where we are going to connect these tables? So we want to have some sort of connection between the products and orders. So that is where our order items came. So in our order items, we need to maintain which order is this part of. And we should also see which product for this it is placed for. So we will also have a product ID. So let's read it in a different way. What we are saying here is every order items which is having a order ID is basically mapped with our orders table. So this will, when we write this particular syntax, what we are saying, every order will have multiple order items, and this order item has something called as a product ID. So we are taking this product ID and then we are mapping it with our products table. So do you see how this played out? It is basically telling, or how, let's write it down, right? So what are the relations that got created after we added these particular lines? So the first one says one order can contain many order items. So hence we have our first one to many relation, right? And we are also saying one product can appear in many order items, right? Because you have stock available and this can reappear until the stock is completed. So this is again, what is this? This is again one to many. So this is the relation. Right now we have done it at the visualization level. Now when we come to the code, this is exactly how we are going to write, and we will see how Spring Boot is going to make it super easy for us. When you're going to do the same thing in a different framework, you will see how complicated that is. But when it comes to Spring Boot, it is way simpler than you can even imagine. So Ani, now that I know, okay, this is the database designed, now tell me, okay, what APIs am I going to build so that I can just really get started with the code, right? So we will have our APIs for product and we will have our APIs for order, right? So let's list them down and then we will see based on this how we will design our endpoints also. So first things first, we need to give a option to create a product. So I'm going with the plural, which is basically matching with the table name also. I'm going to use the post method to create a product. So this will be our create, and I want to give my option of updating a product via put endpoint, and I'm going to give an option to read my product via the get endpoint, again by the same products. But let's say I want to read just an individual product, right? So read single. So what I'm going to do, get again products, but this time with ID. You remember we are saying every product is uniquely identified by its ID. So this is where it actually comes into play. So let's get back to the API list. Now, apart from getting the product, let's say you also want to delete the product. So this is where you run your delete endpoint, again by product ID. After the product, we have our order also. So we need to be in a position where we can place our order. So this will be a post endpoint for orders. Once the order is placed, I want to get the individual order. So let's say I'm going to use the get orders by ID, and then I also want to see all my orders, right? Get all. Again, this will be get with / orders in plural. So this will sum up our entire API list. Now this is the full API list. We understood the requirement, we understood the DB design, we understood what the endpoints will be. Now we will see how Spring is going to help us in making this entire project, but in a rapid pace. This is where the Spring framework comes. The Spring framework. This is an open source framework. This is available on GitHub, but you don't go there and raise some PR and do all those things. Okay, this is just for educational purpose only. Okay, you're not supposed to file any issues or anything. This is, you just open it, see it and close. Okay, now we will understand the Spring framework from a real world example, right? Whenever you are hungry, you would want to go and find in your fridge what ingredients are present. You're going to cook them and you're going to eat, right? So that will suffice your hunger. But let's say you are in so much hunger that you cannot even wait for cooking. So that is where your ready-made food, which is where you can order from online, or let's say you can also do the frozen food, right? So somebody has already done the cooking, just have to heat it up and then eat. So someone else has already gone to market, they bought the vegetables for you, they did the cooking also, and then they gave it in a frozen format. Of course, not everything, but there are some items which are available. In the same way, Spring Framework saw some issues that as developers, what all common issues that we are facing. So we will take a real world example, and from that we will understand. I'll open a website, and then in that we will try to observe what all things are there. Okay, let's go by a real world example. We will take one of the biggest e-commerce application in India, which is Flipkart. You can see they're already asking me to log in. I will do. Okay, wait. So here you see on their landing page, you have some sort of carousel, and then there are products being listed. It is of course not saved somewhere in the API server, but it is in some sort of a DB where the information is present. That information, when I opened the website, it said, okay, someone from Hyderabad is requesting this page. Let me get the information which is relevant to me, right? So it is going to go into their database, going to find, okay, what is most relevant to Anirudh, and then it is going to return, right? You have again this cart login, right? Okay, one more thing. Okay, here we have authentication, right? So this is very common across applications. You will have some sort of authentication which is common, right? So don't you see some commonality in this? Every product will have some sort of DB connection. Every product has to send its information, or in order to communicate, some sort of REST API communication has to happen, and you need some sort of DB connection so that your API server can talk and get you the information. It can persist the details, right? So here, Spring Framework, people around the world who have a lot of interest in this, they came together, they wrote small packages. They wrote what? Small packages which exactly solve this, so that you as developer, you don't have to reinvent the wheel. You don't have to write your authentication again from the scratch. What you have to do is you have to go to Spring, find which is most suitable to you. You are not someone who is going to face this for the very first time, right? This might be faced by someone else already. So they have done the solution, and what they gave is they gave you, you can install this, you do basic configuration, and once you do your configuration as per your application need, then you can get started with the application development, right? You as developer, you focus on actual building, right? For me as developer, what all I have to do? I have to do the DB design. I have to create these endpoints. This is my work. I should not be bothered about, okay, which DB am I going to use? How will I connect to it, right? Those are questions which I will hand it over to the framework. This is where Spring is going to shine. It will say, it will do all the heavy lifting. I'm really telling, this is a bodybuilder, right? This is going to lift all the 25 kgs, 100 kgs dumbbell for you. You just have to go to the gym. So now that you got, okay, from real world understanding, okay, you observe this, something is built for you, you go take that, you add it as a plugin to your project, and without breaking your project, you're going to do some config, and you can utilize exact same behavior across your application. So that is bit about Spring. And if you want to know, okay, what is the symbol of it, this is a leaf symbol, something like this in green color. What is the official website? Let's get into Spring's website. So this is the Spring's official website where they're saying, okay, Spring makes working with Java easy, simple, productive, all marketing terms, right? So here they are saying, okay, what all use cases where you can use Spring, whether it is generative AI, whether it is microservices, cloud, web apps, serverless. There are a whole lot of things, and this is why enterprise loves it. There is a certain reason why enterprise is actually using it. It is not that one day someone wake up at this big company and then said, okay, Spring has a leaf and I find it very much appealing, I am going to use it. No. And there is a reason why companies like Netflix are still using it till today. Now we'll get into the Spring projects. So similar to you as developer whom you have projects, right? So Spring also saying, hey, I have some projects readily available. You can go through them, identify which is most suitable to you, and then you can pick, right? So at the center of all, everything is Spring Framework. So what do they say? Let's read out, right? What does it say? It provides core support for dependency injection, transaction management, web apps, data access, messaging, and more. One common doubt that everyone usually have is, okay, we have a Spring framework, then what is a Spring Boot? You remember in my example where I said we have food which you can cook and eat, and there is also food which is ready-madely available as a frozen food. You just have to heat the food and then eat. Spring Boot is exactly that. So what does it read? Let's read. Spring Boot takes an opinionated view of building Spring applications, and you can get up and running as quickly as possible. And there are more such projects in Spring ecosystem. But right now, let's get started with Spring Boot. We will set up the project. We will see how everything is flowing. We will see how all the files are laid out, how it will run. So let's get started with that. Fantastic, guys. You have followed the tutorial till here. Make sure you drop a comment. I'll send you a guide on how to get rich in 30 days. Now let's open our IDE. This is IntelliJ IDEA. You can download it from the internet basically for free. And here you see there are various options. Let's start by creating a new project. We'll click on new project, and here we will mention this is a creator store. You can see I have a location under which it will be created. I'm going to go by the Java language. I'll be picking the Maven build tool, and in the group ID you can see it has basically entered my own website, which is anirudhjwala.in, in the reverse order. So if you have your own website, make sure you enter it in the reverse order. So it should be something like com.google, right, in the reverse order. The artifact is basically same as the name, and JDK, whatever default it is giving. If let's say you don't have JDK installed, make sure you install it by one of these options that are given in this drop down. The Java version, whatever is default. One thing that I'm going to change is the configuration. Right now I want to maintain everything in the YML format, which is my preferred way of reading. So I'll be going with the YML format. I'll click on next, and here the Spring Boot version is already picked. This is the latest version. Tomorrow there can be something else. So based on whatever is the latest, you go with that. In the dependencies part, let's start installing some things. These are the dependencies which are given at the time of creating the project, but I'll also show you a way. Let's say you already have a project. How do I add a new dependency into that, right? So these dependencies are similar to what you add in your package.json in your JavaScript world, right? So here, firstly, I want to have one for my database. I'm going with the Postgres driver, right? So this driver will help me to connect my Java application to the Postgres database. And next one, I'm going to add one developer utility, which is Lombok. This will help me in getting the getters and setters for any given class. And yeah, of course there are more, but right now if you don't know what is getter and setter, make sure you revise your Java basics. Right now, apart from these two dependencies, there is one more, which is the crucial crux for this, which is the Spring Web. So this will enable us to create and work with REST APIs. Let's say you want to work with GraphQL, right? So that is where you search for GraphQL. And then you add the Spring for GraphQL dependency. So apart from this, there is one more which is very crucial, which is the Spring Data JPA. This is the one which is enabling us. This will act as a ORM for us, and this will help us connect to the DB. Whatever Java classes I'm creating, this will convert those into the database tables inside my Postgres DB. So I'm going to add my JPA configuration. And apart from all this, there is one more, which is the Open API spec. This is not Open AI. This is different. This will help you in getting your documentation for your website. So this is basically, if you know something like Swagger, so this is basically that. So it will help you generate Swagger documentation. But for now, let's click on create, and then this will set up the template and then give me a basic starter guide, right? So from this, we will understand the project structure, and then we will go about what all we have in the project. Onto the left side, you can see there are a lot of changes, and then because I also did git initialization, let me commit this file so that I know, okay, this is where I started. I'm basically showing you how I as developer work, right? So I'll make sure from time to time I do my git commits so that whenever you get this repository, you see everything from time to time, right? So this is the setup, basic setup, right? So I'm just committing, and then I'll just remove. So this is basically the IDE. So here you have commit option, here you have your project structure, right? On to the left side, right? So here you have your file structure, right? So here, let's expand and see what all we have. Okay, initially we have .idea. I have no idea what is this, but I'm just kidding. So this is related to the IntelliJ IDEA. This is the folder which is specific to the IDE itself, so you don't have to touch it. The Maven is in short known as MVN. So here it has the properties where it is saying when I'm going to do my installation of dependencies, this is the location where I'm going to go search for the dependencies and get the dependencies for you. So this is similar to your npm JS registry, right? And next we have src. Okay, we know, okay, something related to source code will be there. We will not open that. Okay, we have our git ignore. So this is a file used to ignore certain folders, files in your git history. Okay, next you have your maven w. This is the actual Maven which is present in your project level, so that you don't have to download Maven every time. Maven is included in your project only. So that is a good thing. So similar to package.json, we have pom.xml. This is an XML format, guys. Remember, this is not in JSON format. This is an XML format. That is why you're seeing all these tags, open tags, close tags, something like a HTML, right? But what we are most interested in, right? Okay, so some things that I saw at the time of creating, this is the group ID, artifact ID, recall. So this is the name. I have some description, right? Okay, these are the things which I'm not bothered about. But I know, okay, there is something like, okay, Spring Boot version, which is 4.5, right? I'm able to understand from this. If this does not totally make sense, I know, okay, by reading this, basic human instinct is kicking in. Now, when we scroll down here, we see, okay, there is a dependencies list. In this, I see each individual dependency is being added, right? So what all we have added many things, right? One is a Postgres, one is a Lombok, one is the Spring framework in itself, right? So what all dependencies we added are going to sit in this place. So this much I can understand. So tomorrow when I want a new dependency, I'm going to go find somewhere and then I'm going to add it into my pom.xml. In the src folder, we usually have two folders, main and test. Main is where your actual source code is present, and test is where you write your unit test cases. In the main, we have Java and resources. Resources have application.yml. At the time of setup, you remember I told that I have a preference of YML. So this is exactly the file which I was talking about. The configuration of my entire Spring Boot application is this particular file. So from this, I can enable some default flags which are currently turned off or on, right? I can do all my control from this particular location. Tomorrow, when I'm going to add my database, let's say I want to connect to my database, all the credentials will be mentioned in this particular location. Of course, not the direct string. I will mention it in my .env, but this is the location where all my configuration is going to be present. Now in the Java folder, we see, okay, there is one file, because when I was working with a Java project, I usually used to create one Java file, which is my main class, and I have just that one file. So this is that one file. This is my main class file. So here you see there is a run button. Let's see, okay, whatever happens. Let's click on run and then see, okay, what will happen. Okay, on the left side, you see there is a target folder which is created, and then this is where your generated output is going to be present. So here, if you expand and see, this is my decompiled version of my Java code. So this is where all my .class files are going to sit. If you don't understand what is .class, go revise your Java. It is a fantastic language. You have to learn it. Okay, now that I appreciated about Java, my application tend to fail. So it is saying, okay, there is some sort of URL which is missing, which I will be adding, right? Because we included the dependency of Postgres, but we didn't really connect our application to the database. That is nice. So my application is actually working. It knows there is certain dependency which is asking for a detail that I am yet to supply. So this is a great start. Now we will get into the next chapter. Let's look at some of the configuration that is needed for us to add so that our application will be up and running. So let's add them. So first we will add our database information. In this, we will be including our data source. If you remember, in our error also it was saying something around data source URI is missing. So we will add the URL of the database. We will have to mention the username of the database and also the password. This information, either you can get it from Neon, Supabase, or you can spin up a Docker machine on your local and then you can get it from there. I will show you how you can do it from a Supabase example. And after this, we will also have to add some ORM configuration. So if you worked with some of the JavaScript based applications, right? If you worked with something like Drizzle, Prisma, Mongoose, you must have seen how it will make our job easy, where you don't have to write any SQL commands, but just do some little programming, and that will automatically do all the rest of the conversion for you. So in our case, we are going to work with Hibernate. So Hibernate is a ORM library which will exactly work in the same way, but for Java. So when it comes to Spring Boot applications, we have a different version of it. So where can I find it? When I open my pom.xml, here you can see we have something called as Spring Boot Starter Data JPA. So this is exactly the package which is responsible for our ORM configuration. So in our configuration, let's add some details for Hibernate. Okay, let's add it as Hibernate ORM configuration, right? So here we will have to mention our JPA configuration. So JPA stands for Jakarta Persistence API. If you don't know what it means, just Google it. This is a homework, so you can write it down. And this, we are going to enable the Hibernate's DDL auto. So in the world of database, when you work with queries, it is divided into DML, DCL, DDL. So this is the DDL which we are telling. So whenever I have a data definition language that is present in my application, I want that to automatically update my DB. So I'm giving a flag of update. There are few more flags that I want to enable. One is the show SQL, so that I know like what exactly you're running in the background, and this will help us in the debugging. And then we will also see in our logs what sort of tables are being created, what sort of insert commands are happening, what sort of select commands are happening when we do our particular CRUD operations. Apart from this, I want to enable few more properties. So properties, here I want to select my Hibernate and format my SQL in a more readable way. So this is one more option that I want to enable, so that this is more in a human readable format. Now in this entire file right now, I'm just missing three information. One is my URL, username, and password. All this information I can either hard code it here, or I can mention it my .env, and from my .env I can load this information into this. So when it comes to production systems, we usually load it from our env file. But where do I actually get my database information? Let's open up Supabase. Right now I'm in my Supabase dashboard. Here I'll click create, and then we'll fill in the details that are necessary, and then we'll get into the configuration part. When we click on create new project, we will see a screen similar to this. Here we'll enter our details, and then we'll get into the next stage. In the project name, I'll enter something like creator store. In my database password, this is something that I have to keep a copy of. I'll just click on generate password, and then I'll keep a copy of it in my clipboard. In the region, I'm picking Asia specific, which is closest to my region, and then I'll click on create new project. This will automatically spin up a machine in somewhere in the Supabase infrastructure, and then it will give you all the details that are necessary for you. Right now, this has spinned up in the Singapore location. Now we want to connect to this DB via our Java application. So here you see there is a connect button. Here we will get into the direct connection, and we will pick a session pooler. This is important. So we cannot go with a direct connection, because direct connections are usually not friendly, and this is not from a pool. Rather, this is a direct connection to the database, which is not encouraged, and sometimes even Supabase kind of rejects it. So in the type, I'm going to pick something which is friendly with the Java, which is JDBC. So here right now I'm getting a shared pool. So in this pool, there are multiple connections available, and based on whenever my application spins up, when my application starts, it will go check in the pool and then pick whichever connection is available. So I will copy the URL from here and then paste it into my application. And in the URL here, I have pasted it. So here I see this is a very big string. Here I can see the protocol is JDBC. This is something very important. You cannot remove JDBC from here. We have our protocol of Postgres, and this is our server where our database is hosted. Here we have our username. Let's copy our username. Let's paste our username here. And then you see it is asking me to enter the password. So the password is already with me, and then I can just remove everything after the query parameter. Now, one way is we either store these as plain text in here, but the risk is whenever I commit this files, this will be available to everyone in the world. So that is not something which I want to happen. Rather, I want to store these in my env, and when my application starts, what is going to happen? I'm going to start it via the main class. So here I have to do some changes so that my .env is loaded and it is available in my application.yml. Okay guys, right now I am on Google. I have searched for Maven repository. This is similar to what we have in the JavaScript world for npm.js. So this is the website which is responsible for listing all the dependencies that we are looking for. It will maintain versions of the dependency and you can find the installation scripts for them. You can, of course, you can find the documentation around it and a lot. So let me open Maven repository, and here we are going to look for one dependency which will help us in all the env setup. So I'm going to look for .env and search. So here in the very first result, you see .env Java. We want to go with this one. For the .env Java, here we have various versions. Let's pick whichever is the latest one, and we'll scroll down here to find the installation script. We'll click here. It will automatically copy to clipboard, and we will get back to our IDE. In our IDE, we have to navigate ourselves to the pom.xml. Here you see there are various dependencies listed. I want to go to the last. Here I will enter and then click paste. I want to remove this particular comment. This is not needed anymore. And once I do, I need to make sure I'm going to sync my Maven changes so that Maven is going to go find this dependency, download it, and make this particular package available for me. For now, I can close my pom.xml, and this is how you search for a particular dependency and you add it into your project. In the main method, let's do some configuration so that this is available. So we will say configuration of .env Java. So let's add .env. So this is coming from the .env package. Here I'm going to create an object for it, so by the name of .env, and then I'm going to say, hey .env, can you add my configuration and ignore if anything is missing and load them whatever that are present in my .env file. Let's add this to our system properties. We are going to say .env.entries. So for every entry that is present in my .env file, so for each entry value, I am going to map it to my system.setProperty, and here I'm going to take the key value as it is, whichever is present in my env file, and then I'm going to pick my get value. So for you to understand this in a more clear way, let me format this so that it is visible to you. Here you can see what we are saying. I'm loading an object of .env from the package that I've installed. And for each value in my .env file to my system that I'm currently running as a process, which is my Java application, I'm going to set the property of key and value that is going to come from a .env file. So let's create a file by the name of .env, and then we will see what to do next. So we will right click here, file .env, and then here it is asking, do you want this to be in my Git? I'm saying cancel. I don't want this file to be tracked at all in my Git because this is where I'm saving my secret values. So here I'm going to maintain the key value format of database URL, database username, and database password. So these are my keys, and I'm going to maintain my values. So if you remember, in my YML file, I was maintaining the plain text. I'm going to copy this information of URL, paste it here, and in the same way, let me do for other fields also, for the username and for my password also. Now I have a location where all my information is saved in my .env. My Java application is going to load this env file whenever my application is going to run, and it will be made available to my YML file. But right now I still see the plain text here. So how do I substitute it with the env values? So there is a syntax for this. So we need to use a dollar symbol, and we need to mention in the curly braces what is the key that you want to load. So I'm saying I want my database URL, and in the same way database username for the next field in the curly braces again, and for the same way in the database password. So now that I have all of this information, we can also check in my Git tracking. I am not committing my env file, and I am committing my application file, but here there is no sensitive information. Now in this way, when my application is deployed to production, I can make sure I can set my env values on the server, and this information is not leaked anywhere to the internet. Now let's run this project and see, does it succeed or does it continue to give us more errors, right? So let's run it and then take a leap of faith. All right, so right now I'm seeing some logs, and then we can see, yes, there is a successful DB connection message where it says database JDBC URL for this particular link has been connected. And then right now we currently don't have any tables to be created. So right now the DB connection is successful and my application is started and it is up and running. And on which port it is running? On port number 8080. So we are done with the setup of the .env. Let me commit this changes and then we will go to the next chapter. So let's stop this server which is currently running. We will go to the commit message. We will write this as chore add.env java for the application. We're done with most of the basics that are needed for our application to be up and running. Now let's start with the actual coding part in itself. So if you remember from our DB diagram, we had 3 tables. So let's go about creating these 3 tables. But where do I create them? Let's follow a proper structure here. So let's create a new package in my main folder by the name of entities. And under my entities, I'm going to create several Java class files. So by the name of product, of course, don't ask me again. Let me add this automatically. So let's mention the attributes that the product table needs, and then we will get into the rest of the part. Let's start with our ID value. So this will be long ID, and then we will have a private string product name, private string description. We will have private string category. We will have private big decimal and price. Let's add one more field, which is our private integer stock quantity. So we are done with our basic fields. Now that we have our product class ready, now we have to inform Spring Boot and say, hey, you can go ahead and create objects for this. You can create table for this. So we need to mention certain annotations. So annotations add some sort of meta information so that this particular class is extending more functionality. So let's add the annotations that are necessary for our class, starting with the entity. Now this entity is coming from the JPA. So we have to import this, and you can see it is coming from the Jakarta Persistence API. JPA table, and here I can mention a different table name. I want to have a plural of products. After this, I want to add my annotations for getter and setter, which are coming from the Lombok library. And one more is the all args constructor and no args constructor. And additionally, I want to use the builder design pattern, which will make sure on the fly when I need a certain field to be set in a certain way, I'm using the builder design pattern for it. If you don't know what is builder design pattern, just Google it and then you will understand this. Again, this is builder design pattern is being enabled by the Lombok library for us. These are the annotations we have added just at the class level, but there are few more things. You have said, Ani, that the ID is a primary key, but you haven't mentioned this in your table, right? Because now when Hibernate comes and checks this particular class, it knows it has to create these. But let's say you want to enforce some restrictions. You want to add some validations for these fields. Let's say your name cannot be empty. Your description has to be in a certain length. So how do we do that? That is when you add your annotations at your field level. So now we will get into the fields. So for each fields, let's add certain annotations, right? Now the first one for the ID, we are going to take from the JPA again with the @ID. We are going to generate this value. This is something which I'm handing over to the database, and then I'm saying, hey, I want you to follow the strategy of generation type identity. You maintain the sequence and then give me the information for this. Now, when it comes to the name, I want to make sure this column is not null. So we have a description which can be null. Our category for now, I'm saying, okay, this can be null as well. After category, we have price. This is an interesting field in itself. Again, here column cannot be null. I'm going to add one decimal min validation where it will say my value of my price should be always be greater than 0. So here my inclusive is false, and then my message says price must be greater than 0. So this is the validation that I'm going to add for the price field. And when it comes to the stock quantity, in the same way, let's add our column to be nullable. But here you see this is in camel case But when it comes to the database, we have to maintain everything in snake case. So we need to have our underscores. So I'm enforcing the name of the column to be something different from what we already have. So I'm going to copy paste here, and then between words, let's add a underscore and the capital becomes small. So this is how we are going to store the database column name. Now here, because this is a integer value, our decimal min will not work. Rather, you have a min value. So here our value will become 0 and messages stock cannot be less than 0. So this is our basic validation that we have added. Apart from this, let's say you want to add little more enforcement. Let's take a look at that also. So for our field where we are saying nullable is false, so it cannot be blank as well. So we have our not blank, and then we are adding a message where it says product name is required. And in the same way, when it comes to our price, this cannot be null value, and then our message will be price is required. And lastly, in our stock quantity, let's add a not null with a message of stock quantity. Stock quantity is required. So in this way, we are done with one of the biggest table, which is our product table. And in fact, there will be more changes on which we will revisit, especially on the relations. So I'm adding a to do that we'll have to revisit here on the relations that we will be adding. For now, we will close our product class and then open the next one, which is our order class. Order class. Now in our order class, as you know the drill already, so we'll have some table level annotations. Let's add our entity. Let's add our table with the name of orders. And the same way we'll have our getter and setter. Getter and setter. There is a different way. Let's say you don't want to add your getter and setter. There is one more annotation. But for now, to be more verbose, let's go with the setter and getter. And then we'll have our all args constructor and no args constructor. And now in the order, we'll have to maintain few fields. So let's write down the fields and then later we'll get into the annotations part of it. So we will go by the private long ID, and we will have one more, which is the private string customer name, private string customer email. Along with customer email, we will also have to track our order status. After a status, we have private big decimal of total price. So this total price is a calculation of each big decimal price value that we have at our product level. Next, we will have one more computed information, which is our local date time for our created at field. So the created at and updated at fields were present in our ER diagram. So the same things we have mentioned here. Now let's add some annotations for the fields that we have added. So this will be the @ID. Generated value will be strategy with generation strategy of identity. And our customer name should have a annotation of column, which is nullable false. And we need to rename this to a different key of customer underscore name. In the same way, we will have to do for our customer email, customer underscore email with the nullable as false. And in the same way, when it comes to our status also, so our nullable will be false. And in the total price, let's add our annotation of column. And here we'll have to make sure our column name is in the snake case format with nullable false. Now when it comes to the created at column, let's add our annotation of column name with the column name as created underscore at. So this is something which we have to pre-persist. So this is something, a method which will run before it saves the record to the database. So here we are going to create a method by the name of public void pre-persist, and here I'm going to say this dot created at field that we have access to. This will have my local date dot now. Now in the same way, you can add the same created at logic in other classes also, but I'm giving this as assignment. And also here we didn't add any extra validations. So now this is a take home assignment for you where you can add little extra validations. And when we actually go about creating our particular order, right, then we will see how we can handle these particular errors, how we will show these messages to the UI. So we will get to know all those things. Now let's get into the next class, which is our order items. So let's create another entity, which is order items. And here we are going to look at what more fields are going to come. So order items will follow the same convention as we did before. We'll have our @entity. We'll have our table with the name of order items. We will have our getter. We'll have our setter, no args constructor, all args constructor, and the builder design pattern, right? So now you know what are the most common annotations that we are going to use in this project. When it comes to the fields of order items, let's write those down. Private long ID, and then you have your integer quantity, and then you have your private big decimal, which I have to import, I believe, price at purchase, and finally we'll have to add our relations here. So to do that, I've mentioned here, which I'll be adding it later. So now when it comes to the field, let's add these annotations, right? So @ID generated value with the strategy of generation strategy dot identity, and in the quantity I want to make sure this will be a column of nullable false, right? So nullable false, and when it comes to the price at purchase, we need to make sure we have a nullable false, and then we are also renaming this particular field as price at purchase. Now this is exactly what we have replicated our AR diagrams, but there is one thing which is missing, the relations of one to many. So right now we have 3 files, we need to connect our tables. So this is where we are going to start. So if you remember the relations that we set between these tables, let's start with the order. So one of the relation that we mentioned was one to many, where we were saying every order will have multiple order items. So we need a field for it, right? So let's add it before, let's say, the created at. So let's say we want to have our private list of order item, where I'm saying order items. And so let me import this list from the utils package, and here I'm going to say, hey, one order will have many order items. And what will this be mapped to? So when I say mapped by, this will be mapped by orders. So where is this particular orders present? It should be present in my order item. So let me open my order items, and here I'm going to add a field where it is going to be by the name of orders. Now in the order items, I want to make small correction. Here I want to make it as order item, and then let me also update the file name. All right. So here we have order item, where we are saying every order will have multiple order items, right? So in this, so this will be many to one, because on the other side we had mentioned one to many. So here we are going to say, hey, private order, I'm going to have my field by the name of order. So this is the field name that I have to map it here. So in my mapped by, I need to mention order and not orders, right? So make sure you do that correction also. Now in our order items, we are left with one more, which is the join column. So we are going to say, hey, please join my column by the name of order underscore ID, and this will be nullable false. So this will add our very first relation between our order table and order items. We are left with our products. So in our product class, currently we are missing one particular relation that is to be mapped, which is our @one to many, and then we are saying private list order item, and then order items. Let's also import my list from the utils, and I have to make sure it is also mapped. It is mapped by the product field, but is this product field available in my order item? Until now, no. So let's add that. So I'm going to say many to one, and then private product, and you know the drill now. So we have to join the column by the name of product ID with nullable false, and one small addition into the product. So whenever I am requesting a product, or let's say I'm getting a product by its ID, I don't want to know the order item, because I am interested to know what all fields that the product has, but not the orders in which the product is present. So I have to make sure I give this @JSON ignore. So adding this property will make sure whenever I'm fetching my product, I'm not accidentally also getting all the orders that are associated with it. So this is a good practice that we have to maintain. Now that we are done with adding all the three tables that are necessary for my project, let me get into my main application and let's say we run this, and then let's look if my application is able to create these particular tables in my database. We will check the logs also. We can see, all right, so there are some changes and we can see the logs also. And because this is running for the very first time and these tables are not present in my database, it has ran this create table, create orders and create products. Apart from this, it has also added a constraint, which is my relation between the tables. It has altered the existing table. It has added the foreign key references with the primary key that is in my original table. So this is the beauty of Hibernate. This is all done by Hibernate all by itself. We as developers, we are just doing the Java code part and Hibernate is doing all our SQL heavy lifting. So let's also verify these in our Superbase table so that we know these tables are actually created. Right now I'm in my Superbase dashboard. I'm opening my project, and here in the table editor, when we go and see right now, here I have three tables that are already created. Let me open my product items and then I can go to the definition and then also see what are the commands that it has used to define this particular table. Let's say you want to look how all my tables are structured. Is it matching my original DB style? Let's get into the schema visualizer. Here, let me collapse this. And here you can see this is exactly the original DB design that we did on Eraser. Now we have done all this via code and we didn't write even one single SQL line ourselves. We have handed it over to Hibernate, and Hibernate as ORM, it has done all the magic. Now that we have completed our models, we will commit these files and then we'll go to the next layer, which is a repository layer. So let's add these to the Git. So let's say chore entities for creator store added. Right, let's commit this files and then we are good to go. So we can close this files for now and we'll get to the project explorer. Now that we have our entities in place, we will create our repository package, using which the repository will be responsible for talking to the database and performing the operations of create, read, update, delete onto the entities. So let's create that. Now in the new, we'll create a new package by the name of repositories. So for our three entities that we created, we have to create its respective repositories so that I can control these particular tables from my code. So let's create the files necessary for it. So I'll click on new, create new Java interface, but this time it will be product repository. And this will be an interface, guys. So make sure you remember that this is not a class, this is a interface, right? Now in the product repository interface, we are going to extend some inbuilt functionality. We are going to take help of JPA repository. Again, JPA is coming from the Jakarta Persistence API, which is going to give us all the implementations that are necessary. And who is going to write this particular implementation? It is being written by Hibernate, right? So JPA is a standard that Java language has given, and whichever ORM we are using, the ORM is responsible for writing its implementation. So let's extend the interface. So the flexibility that we get here is because we are going to extend JPA repository and we don't know what is the underlying ORM. Tomorrow, let's say you want to switch to a different ORM, we don't really have to make much code changes. We just have to give the configuration as we saw in the application.yml, and then we are good to go with our code. So let's extend JPA repository. Now here I need to mention which entity this particular JPA repository will be implemented. So I'll mention the data type as product, because this is for the product entity, and the product entity class currently has one unique identifier, which is by the name of ID. And what is the data type for it? It is of long. So we need to carry forward the same data type into the product repository so that all its unique identifiers are of data type long. Now this is it. We don't really have to add any more methods into this interface, and your underlying ORM is going to do all the heavy lifting, right? So for now, we are going to close product repository. So we are going to create more repositories that will match our entities, right? So we'll click on new, create a order repository. Now product repository, this is not a class. Again, make sure you mark it as an interface. And here also we are going to extend the JPA repository, and you can see it is already giving me a lot of suggestions, which is very nice, right? Now, apart from this, I'll need one more interface, which is the order item repository. And I'm going to, in a similar way, extend JPA repository order item, and then this is of long. Right now you might not really understand why did we even create these interfaces, but when we start writing our business logic, I'll show you how these repositories are helping us to communicate with the database. Now that completes our repositories. We can close this. Now we will start by implementing some controllers. In our original diagram on eraser, we have listed certain endpoints. So let's create these endpoints. And where will these endpoints reside? These will be in the part of controller. So let's create a new package by the name of controllers. And in the controllers, I'm going to have various controllers for my product and order, right? So I'm going to create one for my product controller, and in the same way, when the right time comes, I'm going to create for the rest. So let's start with the product. If you remember, in the product we had read, update, delete, read a single product, read all products. So let's create certain controllers. These are our REST endpoints, which will enable the client, whether it is a front-end mobile app or a website or even your postman, to communicate with our backend. So this is the point of control which all external systems are going to talk to, and our controller is responsible for defining these particular backend endpoints, and it is going to tell which particular functionality is going to run in this. So let's get started by writing our very first controller. In the product controller, as I said, we are going to have certain methods. Let's list them down. In the product controller, the very first one that I want to have is create product. So once I create a product, I should also be returning that particular product. And we will have a method for updating the product, update product. And while you're updating, you need to accept what is the new product with which you want to update, right? So I'm going to accept that. Along with this, I'm also going to accept my ID value. So this ID will tell which product am I actually updating and what are the new fields that I would need in this. So for now, let's return null here, and we will see what all logic goes later, right? So after the create update, I need an option to read the product also. So let's say get products. So here I'm going to return all the products, and when I'm returning, this will of course be a list. So let's declare a list of product, and for now I'm going to return null. In the same way, I'm also going to return a individual product by a certain ID. So let's write that public void get product by ID. So you see how I'm naming my methods, which are very much readable and understandable. So for an outsider, when they come and look at your code base, it is very clearly giving signal that you're trying to perform an action, and it is very much readable. So this is something which you have to follow while you're coding. So let's accept a long ID, and when I'm getting it, I also need to return my product. So for now, let's return null for time being. And after all this, we also need to give a flexibility to delete the product. So public void delete product. And while I'm deleting, I don't need the entire product object. I just need which product you are looking to delete. So I'll just accept the ID value now. So long ID, and then here I don't really have to return anything, so I'm going to mark it as void. So Anirudh, you have written the methods, but you didn't really tell which method is responsible for which endpoint. So that is what we are going to do now. So at our class level, let's add certain annotations, and at the same way, we are going to have some method level annotations which will make this particular class Spring Boot ready. So let's start by adding the @REST controller. So REST controller says I am going to use this particular class for all my REST API operations. So I'm going to mention a particular path under which all my endpoints are going to be available. So I'm going to have a request mapping, and then my endpoint will be /API/products. So every method currently that I have declared here will be available under the suite of API/products. Now this is at the class level. Now what happens to the method level annotations? Let's start by writing those. Now when it comes to our methods, we need to provide certain annotations which will make them eligible for the REST API operation. So it can be a post endpoint, get endpoint, delete endpoint, or a put endpoint. So let's write those. So for my create product, I want to have my @post mapping, and I need to be in a position where I'm going to accept this particular product, and this will be small p product by the variable name. And here I need to make sure whatever product is being passed, it is a valid product, and in fact I have certain validations which are already written at my entity level. So for these validations to kick in, we need to also specify, hey Spring Boot, I want you to make sure whatever information that you're giving me, these are actually valid. And apart from this, because this information cannot be passed, this is an object, it cannot be passed in a URL. Rather, we are going to accept it in the request body. So we are going to mention it as @request body. So whichever client is responsible for doing the post endpoint call, they need to ensure that in the request body, they are passing this product. If you don't know what is request body, I will show you during the demo, but we will go to the next one for now. Here in the update product, right now I don't want a post mapping, rather I want a put mapping where I'm saying I want to update certain information. So I'm going to accept few fields in my URL and then also in my request body. So you see here we are accepting two parameters. So for the ID, it is going to come from my path, right? So I'm going to have my /ID, and then this will be a path variable that I'm going to accept from. And again, here we are going to accept product. So we need to make sure this is also valid. And this is again coming from my request bodies. So these are the annotations which are coming out of the box as libraries when we are working with Spring Boot. So lot of things are being abstracted from us, and we can actually focus on the development part only. Now let's look at the get products, because we are going to get some information. We are doing the @get mapping. Now here we have another get method, but here it has been deferred where we are accepting certain information as ID. Now, where will this ID come from? Because this is a primitive data type, we can accept it in the URL itself. So we are saying @get mapping, and then I'm going to accept this ID in the path. And this value is again going to come from my path variable, where I'm saying in my API path, I have a variable. So you make sure you go and find it. And one more thing, we have to make sure whatever ID we are specifying, this is the same ID matching here, so that Spring Boot can easily match and understand, okay, the user is trying to look for this particular variable in the path. Now let's get to the last one, which is the delete mapping. And then you can already guess here we are going to accept the ID value in the path variable. And let's also add the path variable annotation for this. Now we are done with the skeleton for the product controller with annotations. Earlier we have just written bareboard methods. After that we have written annotations to the class, and later we have written certain methods which are going to help us meet the requirements. And for these methods, to empower them, we have given certain annotations that will make them REST API eligible. Now, Anirudh, are you going to write your entire logic of these particular endpoints in this file? Already this looks a lot bloated. There are so many methods. Let's say tomorrow you're going to add 5 more methods into this, then we cannot really have a business logic in this. So if we are following the proper solid principles, we need to make sure we separate out our logic of creating this product, updating this product, getting products all into separate place, so that we comply by the solid principles rule. So this is where in the MVC architecture, we will get something called as a services folder. In the services, we will have our actual business logic. So all of this setup that we have done so far, whether it is repository, entities, controllers, all of them ultimately have to go through our services, which is our protein of this entire project. So let's add a certain class by the name of product service, and in the product service we are going to handle all of it. So let's inject product service. Now you see I've used the word something called as an inject. So this is called as dependency injection in Spring Boot. So this is something which we will explore in our upcoming lessons. But for now, understand that services file is where you have written your actual business logic. So let's add our private final product service and product service. Now that we have an argument available with us, we need to make sure we also pass the required args constructor so that all these required values are passed in my constructor creation, and all of this is again done behind the scene by Lombok. It will inject the necessary code. So I'm handing off all that boilerplate code writing to the Lombok library. Now let's create this particular product service. When I hover on this error, there is an option where it says I can create a class. But rather than that, I will click on project. In my creator store, I'm going to create a package by the name of services, and in services I'm going to have my very first class of product service. In our product service, we have to create methods which are similar to what we have originally seen in my product controller, so that each method has its supporting service method available. So a convention that I follow is I make sure I have the same method names in my service level also, so that the controller, whenever it is given task, it will hand off that particular task to the service. So let's paste this here, and then we will remove things which are not necessary for us, right? So we don't really need a request body or something here. We're just going to accept it, and then we are going to return the created product, right? So put mapping is not necessary. We don't really need the path variable. So anything that is related and specific to the controller, right? So that we can basically remove in our services layer. So the get mapping and the path variable, right? So all these are very much specific to our controller. So we don't really need them when it comes to my service layer. So you can see I have created my bare bones class where I have all of my methods which will be called by controller, right? So for this service file to be available, we need to add certain annotations by the name of @service, so that this particular service bean is available to me while I'm working in my controller, right? So product service, let me import that, and then let's also rename this as product service. Now we are all good. Now let's complete our controller properly, and then we'll get into the service layer. So here we are saying whenever I receive a create product request, I'm going to use my product service, and then I'm going to pass on this request to my service layer. That is it. This is all the method you need here. And in the same way, let's get to the update product. So here we are going to say product service dot update product, and then we are handing off this task to the service layer. So in the same way, I'm going to have my product service dot get products and product service dot get product by ID, and then I'll pass my ID. In the delete product, I will be following the same convention where I'm going to say product service dot delete product. Now you see, the controller has only single responsibility where it is actually mapping the endpoints, and it is handing off its task to the service layer. So the service layer is responsible for doing all your business logic, and it is also responsible for talking to the database when necessary. So let's visit the product service, and here we will try to understand what we are trying to say. Currently, we got a request where they are saying we have to create a product. So how am I going to create my product? I need to have some way where I can communicate with my database. Oh, that reminds me of something. I have something by the name of repositories. And I also told this product repository has some inbuilt cooked in methods. So why don't we reuse something which is already available to us? So let's inject product repository into our service. Let's add private final product repository, and we need to make sure we pass the argument. So required args constructor, and this product repository is now available for us. So here what we are going to say is product repository dot save, and then I'm going to pass this particular entity. Now you see the request that the service got, it has handed over to the repository, and the repository has cooked in methods via our Hibernate, which is the ORM, and our ORM has all the implementations that are necessary. So you don't really have to write any create command, any insert command, and all of it will happen automatically. So in the same way, let's complete our rest of the methods that are available to us in the product service, and then we will see a proper demo of this. So in my update product, I need to firstly make sure whatever product that I'm saying, hey, can you update this? Firstly, I need to check if this particular product is actually present, or am I just blindly saying, okay, go and update this? No, right? I cannot have such a way of updation. So I need to make sure once the product is actually present, only then I'm going to update it. So let's add my particular product here, and then let's look for a product's existence. So we are going to say existing product, and then I'm going to query my product repository, and then I'm going to say, hey, can you find something by a ID? Then I'm going to say, hey, whenever you find, you return me the details. But let's say you do not find, so return me an error. So I'm going to, and let's say you really don't find that in your database, we need to throw some sort of error. So here we are going to say new runtime exception, product not found with ID, and then I'm just going to print this ID. So let's say you actually find an existing product and then there is no runtime error that it is running into. So we can take the existing product and then say, hey, let me set my name, let me set the description, let me set the category, let me set the price, also set the stock quantity. So I'm going to say set stock quantity and then get my stock quantity. Here you can see I am using certain setter methods and getter methods. So who is this actually providing us? So this is our Lombok library, which is giving all of it just out of the box. So now that I have an updated product with all the new details, I need to make sure it is also saved into the database, not just into the memory. Right now I just did it in memory in my Java application only, but I didn't inform to my database. So for that, I need to again query my repository and then say, hey, can you save this existing object with all the details that I'm giving you? When we fetch this particular product originally, so we have passed the ID and then it really gave us that particular product record. So when we are going to save it again, it is going to go look for that, filter it out, and then going to update with the new details. Now let's get into the get all products. Now here I'm going to say product repository dot find all, and then automatically it is going to give us in the data type that we are requesting. After get products, let's write our get products by ID. So here I'm again going to make use of product repository, and then I'm going to use an inbuilt method which is find by ID, and then I'm going to pass my ID. But there are chances that this ID is not present in the database. In that cases, what can you do? There are two options. One is you return an optional data type and then you say, hey, I didn't really find it. There are chances that this information is present or it is not present, hence the optional. But let's say you don't want to have optional, but you can also choose to throw a error. Let me remove the extra semicolon, and you can also have some sort of runtime exception and handle that exception where you're saying, hey, this particular product is not available with me. Now in the delete product, this is fairly simple. I just have to use product repository dot delete by ID. Now with that, we are summing up the entire MVC flow for our product entity. With that, we complete the entire product flow. We have started with the model creation. We've seen how this will be created in the database. We've set up a repository which is responsible for talking to the DB. We have created a controller where this will be exposed to the client so that the client can go request for a certain information at a particular endpoint, and the controller, following single responsibility principle, it is going to hand off its task to the service. Now here in the service, we are going to have our business logic, and whenever we want to do some sort of persistence, then only we are going to go request our product repository and then going to say, hey, can you save this? Can you update this? Or can you delete this? So these are the operations which are given to us just out of the box while we are working with Spring Boot. Now, in order to test it, I'm going to take help of Requestly, which will act as our API client. So before that, let's run our application, and then once it is up and running, then we can get to the next part. So we can see, yes, my application is up and running and the DB connection is done. So let me open my API client. So this is Requestly, a totally new install. Let's create a new collection in this, and we will name it as creator store, and under this store we are going to have some requests. So I'm going to add a request. This will be of HTTP type. Here I'm going to start by create a new product. Now let's collapse this, and then we're going to save this. Now in this, the type of the HTTP method will be of post, and our URL will be http:// localhost 8080, which is the port on which it is running. In our request mapping, if you remember, we gave a API path of /API/products. So products. Now in this, we need to pass a request body, which we were originally accepting in our create product method. So we will get to the request body. In the raw, I'm going to select JSON, and then here we are going to add the details. So let's say I'm going to add my detail of t-shirt, right? So t-shirt, and then I have a stock quantity of 100, and let's say the price of this is currently 199, and then I have the description, which is optional, so this is not necessary. I have a category, and this gets into the apparel section, and let's run it and see, does it give us any error? Are we missing any information? And then based on that, we are going to see what to do next. Let's click send, and then you see, because my description was optional, my rest of the information using which I have passed in my request body, it did create an object for me, and it returned with a new ID of 1. And this ID is auto generated by database, so I don't really have to do anything in this. After t-shirts, I want to create few more products, so let's use the same endpoint for this. So here I'm going to say stickers, and then stickers will be a little less price, and I'm going to take in more quantity, let's say 2000 this time, and then this is in the accessories category. Let's save this and let's send. So I have my another product also ready. Now that I have created the products, let's read and see what all information I have so far created. So I'll click the press button, and then I'll say read all products. And here I'm going to copy the same endpoint. And in this will be a get endpoint. So in this, I'm going to click send. And in my response body, you see I got a array, which is a list. And in the list, I have the product objects. This is exactly matching how I am sending in my controller. Now let's create one more route. This will be for getting individual product this time. So let's keep it in our creator store collection. Let me duplicate this. And this time in the copy. So let's say get individual product, right? So in this, we are going to pass a path variable. This time I'm going to send the path variable of ID 2. Now we are getting the individual object this time, which is the product of stickers. So let's save this. Now on to the next operation. Say your product has started becoming viral. Everybody started buying stickers. Now in order to do that, you need to firstly increase the quantity and then also increase the price, because you can make more revenue. So let's say update the product. Now here in this product, I'm going to update my product, which is of 2. Here I'm going to change the mapping to put, and in my request body, I'm going to pass certain details. So this will be of JSON type. And of course, in the stickers, this will be of stickers. Let me add some description. I'm going to say viral product from Instagram. And then accessories will be as it is. In my price, I'm going to bump it up, and then I'm going to make it as 150. And in my quantity, I'm going to make them as 9,000 this time, right? So I have a very large quantity available so that it meets the demand. Let me click send. And right now you see there is an updated information that I received. I am not having the older information. Now, how can I confirm this is the case? If I go back to my get all products and click send, so you see now we are reading the latest details from the database. And now even if I close my backend application and restart, the information will still be persisted because all these are coming from my database server. So let's also check that claim, right? I'll stop the application and then I'll restart. Then we will see, are these exactly working as expected? So let's restart this so that we can check the claim, that is my DB actually persisting the information or not. And then, okay, now that this is running, let's wait for the DB connection. Okay, that is also done. Now I'm back in my requestly. I'll click send, and then you should see, yes. Now I'm still getting my same information and no information is deleted. Now that reminds me, we have one more endpoint, which is to delete the details. Let's say I duplicate this, and then here I'm going to say delete the product, and then my HTTP method becomes delete. Here I don't really have to send any information, right? So I'll save this and then I'll click send. So right now my particular product, okay, by mistake I have deleted product 2, but you understand the intention, right? So let's say when we are going to read the product, I'm going to get only single product now. And it has deleted the product too, which is the stickers, and then I'm left with only one product, which is the t-shirt. So that is the full CRUD operation on product. Now we have few more entities which are left, which is the order creation. So now that you have done all the listing and everything, you also need to accept the orders, right? So let's look into that. We understood that we are able to do all the CRUD operations on the product, but we haven't really accepted orders. So in order to do that, we have to firstly create something called as a DTO layer. So having this DTO layer will make it simple for us to accept orders, because when we get into our entities and look in the order here, we currently have a lot of relations and a lot of things in place, but we don't want to capture our relations while we are creating the order. Rather, actually send only the information that is needed. So we'll keep the order open. We will create a new package by the name of DTO. In our DTO, we will have two classes again related to our product, where we will have minimal information only that is needed, and we will exclude the ones which are not necessary. So let's start with the very first one, which will be order item request. And in this class, we will specify the fields that are needed for us. So we would firstly need getters and setters, so that for these fields, whenever the time comes, the application will automatically do the operation. And then apart from that, we need the no args constructor and all args constructor, and of course our builder pattern. Now in the order item request, I'm going to accept firstly the private string product ID, so that I know this particular order item is of which product we are talking. And after that, we are going to have one more product integer quantity, so that you know this particular order item has different quantity in these. Now we have added annotations at the class level. What you know, right? What to do next? We are going to add the annotations to the field level. So let's add that. In the product, I will have something called as not null, and then I'm going to say a message that product ID is required. And for the quantity, we will have again similar not null, and then I'm going to say quantity is required. Now when it comes to the quantity, there is one more check that I want to keep. I need a minimum value of at least one quantity should be present while you're placing the order, and then the same validation message of quantity must be greater than 1. Right? So this is the order item. In fact, this is basically representing a simplified version of order item class. And why exactly do we need this? So that when the user is making request, they are going to just pass the order item request inside the bigger order object. Now let's create the order request as well. So we'll create order request, and then the class will be ready for us. Now in the order request class, you know the drill already. We need to add our getters, setters, no args constructor, all args constructor, and the builder design pattern. Now that we are done with all this, let's add the fields which are only necessary while we accept orders. So obviously you will have some customer information. So let's add private string customer name, private string customer email, and then along with that we will also have private list of order item request, and then the items here. So let me import the Java list. So we have the necessary attributes, and then now we are left with the validations to be added on this. So we cannot have a blank name. So we will have a message that customer name is required. So in a similar way, we will have a not blank for the email as well. And then we will say message customer email is required. And we will have a validation of email, so that they're actually sending a formatted email. So messages enter a valid email. And on the order items, because this in itself has validation, so I'm going to add @valid, and then I'm going to say not empty. I need minimum one item in this. So order must contain at least one item. So this will sum up our DTO layer now, which makes us easy to accept orders without any relations to come in place. So in my entities where I have my order, I need to make sure I also have the back referencing. So I need to say JSON managed reference, and then here the cascade will be cascade type dot all. And in our order item, where we have a relation for this particular order, I need to also mention the @JSON back reference. In the order item request, I want to make small tweaks. I want to make sure this particular product ID is of long data type and the quantity is messages. Quantity must be at least 1. So this is a more clear messaging than the one which is before. Right, so let's comment this and then now we'll get into our service layer. So in the service layer, I believe we know what to do. And in our order service, this is where our entire application comes together. Here we are going to make use of two particular services. One is the private order repository. Let's add order repository. And then of course we have our private product repository so that I can deal with my products. And so here we need to make sure this particular class has all the necessary annotations of service layer by mentioning @service and then required args constructor so that these two fields are injected via the constructor. In our order service, let's add the method which will help us to create orders. So I'm going to say public order create order, and then I'm going to accept information in order request, which we have created as a DTO layer where we have only the necessary fields. So let's add that, and here let me import the order class also. And once we have that, here I'm going to return null for now, and we will write the business logic that is necessary for this. So our order creation has to be transactional, and this will come from the Jakarta persistence API. And why exactly did we add transactional here? Because when we are placing an order, we are making sure this creates a new record in the order table. We have a linking in the order item, and there is an update to the stock in our products table also. So for all of these sequence of events, which is more than one SQL statement to run, we usually group them all into one single transaction so that if anything goes wrong, there is a proper rollback, and if everything is good, we will do a proper commit for that transaction. So let's get into the logic of creating order. So here I see I'm going to return a order object as my data type. So let's create a order object, and then for now let me just return this order, right? So this much we all know. Now from our order object, let's set some properties which we are getting from our order request, right? So let's say order dot set customer name, and then we are going to say order request dot get customer name. In the same way, order dot set customer email ID, we're getting it from the email ID which we have supplied in the DTO. And we will update the order status. We will say order dot set status, and then I'm going to say confirmed. So now that I have my base order object ready with me, there is little more logic. This is very fairly simple. We are getting some products in the request. So we need to go and check in our products table. Is the stock available? If it is available, then we need to add it into our total price, and we need to make sure there is a record for it. So for that, we need to iterate over the items that we are receiving as a request in the order request. So for order request dot get items, I'm going to iterate on each and every particular item value. So I'm going to say this is a order item request, and then item request, which will be used to iterate on this entire list. And then I'm going to do some particular logic here. So firstly, I want to see, is my product really existing? So in my product repository, and then I'm going to go and find this particular item by ID, where I'm going to say the item that you're requesting, I'm going to get the product for it, and then I'm going to look for it. If this particular product is present, I'm going to return it. If not, I will be. So I'm going to throw an error. So I'm going to say new runtime error, product not found with ID. And then here, let's specify the item request dot get product ID so that we know what we are returning exactly. So let's say the product is available in the database. We also have to check in our stock. It is not necessary that it is in stock, so we need to add a layer for checking that. So check the product stock. In order to check the product stock availability, let's write the logic. So we are going to say, hey product, in this, can you get me the current stock quantity? And based on this, I'm going to check it against what items the user has requested. So I'm going to get the quantity. And let's say the user is requesting something which is more than the stock, then we need to throw a error, right? So this is what exactly we'll do here. So here we're going to say throw new runtime exception, and then we're going to say not enough stock for this particular product, and we will proceed to the next step. So we have our basic checks in place. Now we need to calculate the total price for all the items that the user is requesting. So we will write the logic for that. So we will say calculate total Now, in order to calculate the total price, we need to maintain some sort of global variable where we will have our big decimal. We will say big decimal dot total price, and then big decimal dot, let's start with the 0. While I'm calculating, I'm going to say total price dot add, and then I'm going to add certain price here, price of item. So here each price of item is calculated based on how much quantity it is requested and what is the current price of that particular product. We're going to say big decimal price of item equals to product dot get my current price, and I'm going to multiply it with big decimal dot value of item requested dot get quantity. So basically I am multiplying it by the quantity of its current price so that I will get my total price, and this keeps adding up in this entire for loop. Once I have my total price calculated, I need to update the product table with latest stock quantity. Now that we have the total price in place, we need to make sure our stock is also updated. So let's do that. So we have our product dot set stock quantity, and here I'm going to get my product dot get current stock, and here don't follow AI. So it is giving me the wrong code already. So I'll get the current stock, and I'm going to reduce by what the user has requested so that we will have the latest information. So let's say I have originally 100. User has requested for 50 items. I'm going to remove the 50 and then update it with the ones which are remaining. Now into our product repository, now that we have this, we can save our product, and then we are going to do our final calculation of total order items. Builder pattern to make object. So which object are we making? I'm going to make the order item dot builder. So we don't have to use the new keyword in this. Rather, we are going with the builder pattern, and then I'm going to say dot order, and then I'm going to give it the order object which we have worked on, and I will be saying dot product, and then this is the product which I'm purchasing, and then in the quantity the user has requested me dot get quantity, and in my price at purchase I have my product dot get price. And using all this, I'm going to build my order item which will stand in the junction table which we originally discussed. It will have all this information. It will make sure it has all the one-to-many and many-to-one relations, whichever is needed. So we have done all those. Now we are just looking on the business logic. Now that we have our order item, we need to make sure we save all this in somewhere, and then we return it to the user. So I'm going to say order items dot add order item. But where is this order item present? We need to create a list for that. So here let's create a list, temporary list, which will store our information, and this will not be get items. We will say new array list. This is a simple array on which we are adding our details. Now once we are done with the iteration, we need to also update our order object in itself. So I'm going to say order dot set order items, and then I've used the temporary list which we have created, and then let me also set the price for it. So I'm going to say order dot set total price, and then I'm going to get my total price value which I have computed it during this particular iteration. Right, now that we have seen our service, let's create our controller for this particular order service. So in our controllers, we will have our new order controller, and in this file, this is fairly simple. We have seen it already. We have to add the REST controller, we have to add a request mapping, and then here we are going to have /API/orders, and then we need to also give our required args constructor so that we can inject our private final order service. So order service we have created, we need to inject that also into our controller. This is exactly where we are going. Hey, let's have a public method which will return a order, and then I'm going to create an order for it, create order, and in the request body I'm going to accept something, but before that let's import our order. So I've imported my order class, and in our create order method, let's accept the request body. So we will send information that is only required. So we will be passing the order request, and then I need to make sure our validations are in place. So I will say @valid, and now by just using the order service, I'm going to say order service dot create order, and then I just have to return this. That is it. Now our controller is handing off all the tasks to the service layer, which is doing the transactional operations. So firstly, we will start our application. I'm going to my main class. This is my creator store application. Let me run this. And once it is connected to the DB, we will get into our requestly. And in requestly, there are various products which we already saw. Let's add one more request. This is for create order. And then this will of course be a post route. And this will be a HTTP localhost 8080 /API/orders. So here I need to pass some information so that my order is placed. So let's go for that. So I'm going to say customer name. I'm going to say Anirudh, and my customer email, I'm going to have anirudh@gmail.com. After email, let's add some items to the cart. And then here I'm going to say this will be a list, and in each list I'm going to have my product ID, and product ID will be 1 because I have product ID 1 when I go to get all products. So let's say here I'm fetching all the products. So what all do we have? We have t-shirt with the ID of 1. So let me go there. Here I have my create order in my request body. So I'm also going to mention I want 5 t-shirts for this particular order. So I'm going to mention this. Let me add a comma, and then we are good with the request body. Let's correct the request body first, and then we are good to try this out. Let's click send. Okay, now the request body is still correct, but there is some sort of error. Let's debug that. Okay, so right now we are in our order service, and based on this error, let's try to see what is missing. Okay, one thing which I can immediately see here, for our private variables, we don't have the final one. And okay, we can also see the order repository is not used. Okay, so where can it be possibly be present? Okay. Oh, right now here we see we are just returning the order object itself. That is wrong. Here we need to use the order repository and save the order. So that will return as an order object in itself, right? So that is the issue. Let's restart this, and then we should be good to create the order in requestly. So these sort of errors are very common, right? So that you know this is how debugging is actually done. Let's get into requestly, and then we will see the creation of it now. It has taken time, and then it did return me the details. We have our order, we have our customer information, we have the status, we have the total price, which is dynamically calculated based on the quantity. And then it is also telling which order items does it have and what all product is it related to. And we also have our created at time. So at this time, this particular product has been placed. So I'll give you 2 assignments. Make sure you complete them. Take a screenshot of the completion and then post it on social media. So the very first one which we want is get all orders. And then we want one more, which is get order by ID. So we have seen, right, every order has a particular ID. So let's say I want to get this particular order by its ID. So let's say somebody is looking for the tracking status of an order. So this is very fairly commonly asked. So here I'm going to add some particular methods for you. So we will have list of orders and then get orders. I'm going to have a to do here where I will say to be implemented, and then I'm going to return null for now. So this will be a take home assignment for you. In the same way, let's add one more method for the get order by ID. So this will not return a list, rather this will return a single order. You know, right, what to do? We have to get into our service layer. We need to write the supporting methods for this. Once we have the supporting methods, we just wire it up here, and then we are good to test it on requestly. So one aspect of this entire backend application that is still pending is our Swagger documentation. We have installed that originally while we are creating our project in the prom.xml, but we haven't yet used it. So let's see how to do the setup of the Swagger. Before that, let's commit our changes which are related to the order module completed. The very first location from where I would like to start is in my pom.xml. Here we have one dependency which is helping us in the documentation. If we search for Spring Doc, you can see we have added one dependency which is the Open API specification. Now let's run the application and see when we visit the Swagger documentation URL, does it actually give us anything or is it empty for now? Our application is up and running. Let's visit the Swagger docs. So this is the URL for Swagger on localhost 8080. It is currently running, and we have a swagger-ui /index.html. So this is the location where we are able to find our Swagger documentation. You can see this is nicely kept in the dark mode. And here we have 2 controllers which are listed. As I said before, controllers are something which are client facing, And here we are getting list of all our CRUD operations. So we can look up for some information. Let's say I had my t-shirt, right? So let's say I'm looking for that. So I'm entering my ID 1. If I execute it, I should be getting my t-shirt as the response. So you can see I got a status code of 200 and this t-shirt details. In the same way, when we want to set up our order controller, we can come here, click on the try it out, and then here we are getting an example request body where you don't have to really guess. In case of Requestly or Postman or any other API client, you have to be aware of the format. But because we have this dependency which is intelligent enough based on which request body, which path variable you're accepting, it is asking you to fill that up in your form. So let's say you have your put endpoint. When I click on try it out, because I have my path variable as well as the request body, you can see it is clearly asking me to enter the ID value followed by the request body. So this is the flexibility and convenience we get with Swagger documentation. And we as backend developers, we hand over this particular Swagger documentation to the front end guys, and they will test out our APIs. With that, we come to the end of the video. If you enjoyed this, make sure you drop a like, comment, and also subscribe to the channel, and we'll see you in the next one.